In this lecture, we are going to see about the directional control valves. We all know that any hydraulic or pneumatic system will have various important components like pumps, pipes or pipelines, filters or strainer, hydraulic oil storage tanks, heating elements, electric motors which drives the pump, and the hydraulic motors which performs the work. Now out of all these, one important component which renders the hydraulic system useless is the directional control valves. The directional control valves alters the direction of hydraulic fluid within the system such that there is no additional pipelines are required. The control of the hydraulic fluid can be obtained precise and smooth. So this lecture is all about construction, symbolic representation and step-by-step procedure of learning all about the directional control valves. So in any hydraulic system, how do you represent or how do you identify a directional control valve? Usually these are represented by a square symbol. Just draw a square. This means this is a control valve. For two position valves, draw one more square. And for three position valves, draw one more square. Now each square represents a position. Remember this. So if you have a single square, that is only one position valve. If you have two squares, that is two position valves. If you have three squares, that is three position valves. Now something must be running through your mind. What is a position or what are these positions? A control valve slides within a cylinder and then it alters the flow of the fluid. So if you have a three position valve as indicated by three squares, so it means that the valve can operate in three different positions which can connect the ports in different ways. So that's the meaning of it. Now you would be asking a new terminology which I used, ports. What are ports? Ports are nothing but drilled passages or holes through the control valve within which the oil passes through. Let's say you have a three position valve block like this, or let's draw a simple square. If I have this valve in the hydraulic system without any passages, there will be no oil flow through the system. The oil will stop at this point and stop at this point. So you require ports to connect the passages so that the oil flows through it. So in this case I can make the connection like this so that the oil flows from this port to this port. So in this case, this is the entry port and this is the exit port. Entry and exit. So on the valve block of the directional control valve, somewhere the oil should enter and somewhere the oil should exit. So with that in mind, let's proceed with the basic three position valves. We have seen that, to recap, we have seen what are directional control valves, what are positions, and how to identify the number of positions, which is 3 square means 3 position. Now we are talking about ports. What are ports? Ports are nothing but drilled passages through the valve block so that the oil or any fluid can enter and exit to perform work. So we have seen what are ports. The next is, how many ports can a control valve have? How many ports? Okay, so a control valve, based on the number of positions, it can have as many ports as possible. Let us take a square. In this square, it can have 2 ports, 3 port, and 4 port. In rare scenarios, you will have 5 ports. So a single block or single square or a single position can have 5 ports depending upon the type of application. Now you must be wondering why I have drawn an inverted T over here. So to represent in any hydraulic drawing, we have to draw each and every port as inverted T. So I will draw once more a 3-position valve. So that's one square, one position. The second square, and let this be the third square, that is a 3-position valve. So to indicate the ports, it is usually represented in the center, that is central block. This is a single port, the second port, the third and fourth port. So now we can always say that this valve is a 3-position, 4-port directional control valve. This is how we give the nomenclature for this control valve. If the valve is having just 2 squares or 2 positions, we say that it is a 2-position, 4-port directional control valve. You have to count the number of ports and number of positions and say that it is a directional control valve. Now, in this case, we have 4 ports. So let's name the ports so that we can identify them, because we have to connect the inlet of high pressure fluid and exit and then the return. So it is always better to name them. Let's name it as P, the port P, the port T, port A and port B. Now we have a new terminology which is coming into place, that is tandem center. This is very common in any hydraulic circuit, or if somebody asks you in an interview what is a tandem center, it means a position that is a directional control valve with the ports P and T connected like this and A and B are blanked or open like this. This means any high pressure fluid from the pumping system. This means any high pressure fluid, either hydraulic oil or high pressure air, can enter through the port P and then it returns back to the tank T. So that's why I indicated it as port P, that is pressure, and T, back to the tank reservoir. We can put the tank or represent it as like this and then just scribble like this. This means it's going back to the tank, draining back to the tank. Now port A and B are connected usually to a piston or hydraulic motor which performs the work. Now this position where the port P and T connected and A and B left disconnected are tandem center. Let's have a recap. We have seen what are the basic components of a hydraulic system, out of which directional control valve are very important, and we have seen what are directional control valves. With regards to directional control valves, we have seen the position, that is what are positions or how you count a position. With the 2 square it's 2 position, 3 square it is 3 position, and then we move on to ports. The number of ports means the number of drilled passages through which oil can flow. In this case this is 4-port 3-position directional control valve, and after which we have named the ports. P stands for pressure, T stands for return back to the tank, A and B are the ports which are connecting to any hydraulic piston or motor. And then we saw what are tandem center, or what is a tandem center. which is this position. Let's move on to the next topic, springs on control valve. Let's say I take a classic example of a 3-position 4-port directional control valve. These are the ports, pressure back to the tank or drain, you connect it, and this becomes the tandem center. Now, how does the valve close or get centered? I'm going to put springs here, which means if the valve is going to move either way, the springs are going to bring it back to the center. That's why I have indicated springs at the both ends. Now let's see how does that work. So to understand the working of the springs, we have to actuate or shift the valves. How do we shift it? We can draw the ports like this. Now I'm going to have a lever or a button like this, and here are your springs. Now before that, we have to understand what are the ways through which the oil can travel. We have seen position, that is position 1, 2 and 3 ports, 4-port P, T and A, B. Now you have to draw or understand the positions. What are these positions? Conventionally, these will be the direction. Okay, so now with this in mind, here you have the tandem center, and here are the first position, that is, this is the first position, the second is the tandem center, the third. Now I have springs, I have an actuating lever. This is right side of the lever and this is the left side. When I am going to push this lever to the right, what is going to happen? The ports or the cylinder, the spool valves inside the cylinder of the control valve are going to shift, which means this particular position, the ports are going to shift. A will come here, B will come here, P will come here, and T. Let me use other color so that we can understand better. When I move it to right, what happens is the valve shifts so that the port A comes here, the port B comes here, P and T, that is pressure and back to the tank, comes here. So the high pressure fluid from the pump goes through this direction, through this arrow, goes to port B. So these are the passages through which the oil or fluid passes through to B, and then there might be some piston or motor. The hydraulic fluid under pressure performs work, and then the return exhaust or drain comes through port A, and this is connected back to tank. That goes to the tank. So let me indicate the high pressure fluid which is entering through port P as red in color. That's high pressure. It goes through port B, and then the low pressure or the exhaust comes through, let me use black color. The exhaust comes through, sorry, I'm using brown. Exhaust comes through port A and back to the tank T. So this is what happens when I move the lever to right. Now it performs some work as I move the lever. Now what happens when I release the lever? As I release the lever, the spring pushes back and brings the valve to this position, that is tandem center position. Then the flow of fluid stops going to the passage B or the port B and A, and the high pressure fluid goes to P and comes back to the tank, which means this is just circulating. No work is being performed either moving the piston or the pump because these two ports are disconnected. So as I move the lever, the valve shifts and the spring is compressed and thus it is charged. As I release the lever, the spring pushes back and thus you get the tandem center position again. Now I can have one more lever, that is, the same lever can be moved to the left and then valve can be shifted. However, for clarity, I am drawing one more lever over here. Now what I'm going to do is move this lever towards the left so that the parallel arrows, this comes to here, which means, let me explain it clearly to you. You have the 3-position control valve. You have the ports here. Pressure back to the tank, port A and B. You had the cross, which we have seen in the last slide, and now we have the parallel stuff or parallel ways here, and you have the actuating lever, and you have one more actuating lever on this side. I'm sorry, it doesn't come straight. Now I'm going to add the spring here. Okay, now we have seen, oh sorry, I forgot to draw this a tandem center. Usually because the pump will be running, high pressure fluid will pass through and then circulate back to the tank until and unless you give an order for the valve to shift or move. We have seen the movement of the valve and it's working when I move it to the right. Now we're going to see the movement of the valve when I'm going to move it to the left. As I push this lever to the left, the spring is going to get charged as the valve shifts to this position. So here comes the port A, here comes the port B, just directly it comes, and here comes the pressure and here comes back to the tank. So the high pressure fluid, which I will use red color, the high pressure fluid from the pump passes through this port and then goes to A, and then the exhaust will come from the port B back to the tank. So in the previous slide we saw the high pressure fluid going through across, that is P to B. I'll write it for you. In the previous, that is right shift or the right lever, when you operate it, the ports P and B are connected and A and T are connected. When I move it to the left, here P and A are connected, B and T are connected. So it just high pressure oil goes and then comes back. As I said earlier, the spring gets charged or compressed when the valve shifts. When I release the lever, the spring pushes back and thus it attains the tandem center position, that is the neutral position, which means the high pressure oil now circulates back to the tank. So with this in mind, here is a 3-position, 4-port, 4-way, spring-loaded, manually operated directional control valve. So let's recap it once again. How do we name it? We name it as 3 positions, that is first square, the second square, the third square. So 3-position and 4-port. Number of ports on each position is 4. 4 ports. Then you can always say this is manually operated or lever operated. Manually operated, spring loaded or spring centered, spring loaded, directional control valve. So that's how you name a hydraulic or pneumatic directional control valve. Here is the nomenclature. Now you can also say that it's a 3-position 4-port 4-way, which means you have 4 different ways in this valve it can operate with. The first way is this, second way is this, third is this, and fourth is this. So these are 4 ways in this valve. That is, 2 ways are cross and 2 ways are parallel. So that's why we can always say 4-way. So that concludes the first lecture on the basics and construction with symbolic representation of a directional control valve.